Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Saiful Bahri from section 01G of BMM2673, which is Thermodynamics, and I'm going to present my project about thermal energy. So let's start. What is thermal energy? So thermal energy is the energy which is possessed by a system due to the movement of particles. So in this case, they are kinetic energy within the system. So thermal energy is naturally the energy which is caused by the movement or the kinetic energy of the particles. So how does thermal energy happen? So thermal energy occurs when there is a rise in temperature. So when there is a rise in temperature, this will cause the particles in the system to move faster and collide with each other. So this collision will generate the energy in the system, which in this case is the thermal energy. So as you can see in this in on the slide in the right, so thermal energy is the total of all kinetic and potential energy of the atoms in an object. So when thermal energy increase, the particle will also gain movement speed. So their movement will become faster, and so when there is a change in thermal energy, this this can also lead to a change in phase. So for example, a liquid can turn to gas when there is thermal energy present. So water can change to vapor and so on. So thermal energy, how to formulate? So the formula for to find the thermal energy, as you can see here, delta Q equals to mc delta T. So delta Q is the change in thermal energy. M is the mass of the substance in which we are going to calculate. C is the specific heat capacity. So it depends on the type of substance. So for metal, it will be different, and for wood, the C will change to the value of the C. And then delta T is the change in temperature. So the temperature difference between one point to another. So initial and final. So final minus initial, we get delta T. So let's look at this example. We have two objects. One is cold and one is hot. So what is the comparison? So for cooler object, they will have a small thermal energy compared to hotter object. They have a large thermal energy. So why is this? Why do cooler objects have small thermal energy? This is due to the small kinetic energy of the particles in the object. So the particles in this cooler object, they don't have a lot of kinetic energy. So as we recall, temperature is directly proportional to kinetic energy. So when the kinetic energy is low or is small, the temperature will also become low. So in this cooler object, they will have a low temperature. So for hotter object, they have a large thermal energy due to the large kinetic energy in the object of the particles. So again, temperature is directly proportional to kinetic energy. So they will have a high temperature. So moving on. What is heat? So heat is the flow of thermal energy from a warm object to a cooler object. So heat transfer occurs until both touching objects have the same temperature. So as you can see here, this is a warm object, this is a cooler object. So heat will flow from hot object to cooler object. in the form of thermal energy. So this heat transfer or heat flow will happen until both objects have the same temperature. So this state is called thermal equilibrium. So thermal equilibrium is obtained when touching objects within a system reach the same temperature. So at first, look at here. The hot object have 100 degrees Celsius and the cooler object has 0. So the heat transfer will occur until both objects have the same temperature. In this case, 50 degrees Celsius. So what are the types of thermal energy transfer? So there are 3 types. So the first one is conduction, and then convection, and thirdly radiation. So what is conduction? Conduction is the transfer of heat or electric current from one substance to another by direct contact. So as you can see in the picture, the pot. So conduction happens at the handle of the pot because we are having a direct contact with the handle. So heat transfer, direct contact. So secondly is convection. So this is the transfer of heat through a fluid, so liquid or gas, which is caused by molecular motion. So convection is only for liquid or gas only. It is not for solid. This is because in solid the particles free don't have their freedom to move freely. So the particles only vibrate in one spot, so they don't move. So convection cannot happen in solid state. And the last one is radiation. So in radiation, energy that is radiated or transmitted in the form of rays or waves or particles. So radiation, as you can see this line, it is transmitted through electromagnetic waves. So they are not in the solid or liquid state. It is in the form of waves, or we call electromagnetic waves. Okay, what are the formulas for these 3 processes? So for the first one, conduction, we write Q equals to negative K T. So where Q is the local heat flux density and K is the material conductivity and T is the temperature gradient. Okay, so convection, we write Q equals to H delta T, where Q again is the local heat flux density and H is the heat transfer coefficient, which is W dot M negative 2 dot K, and change of T is the temperature difference, as we know. And then radiation is Q equals to epsilon sigma T power of 4, where Q is the power radiated from an object, sigma is the Stefan Boltzmann constant, and epsilon is the emissivity of the surface of a material. So these are the 3 formulas for conduction, convection, and radiation. So thermal energy, we get the final value in the form of joule. So that is all from me for thermal energy. Thank you.